I'm going to go ahead and show you how to make a data table and graph in Excel. This is the way that we do it in all of our physics labs, whether they be formal or general, if they are being done online. It seems intimidating at first, but it's actually pretty easy, and in fact, it's much faster than doing it by hand. I'm going to use Excel. You can use Google Sheets if you prefer. So everything that I do here may not translate exactly over to Google Sheets, but a lot of it will. Some of the buttons and odds and ends may be in different places. Along with that, I'll show you a few tips and tricks to go ahead and make the table and graph look actually nice and neat and worthy of presentation. So in order to do this though, I need to have an experiment that I'm going to go ahead and record data and build a graph and demonstrate to you how all of this is done. So I went ahead and mocked an experiment in which here's some kid named Billy, and Billy drops a red ball. And what he does is he starts 1 meter above the ground, drops it, times how long it takes to hit the ground, goes up to 2 meters, 3 meters, 4 meters, 5 meters, etc., etc. Ultimately, Billy drops it 10 times. Sorry about that. This should be 10.5. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 meters are his drops, and these are the times that he records with a stopwatch. If you actually do the calculations, you'll find out it doesn't quite fit the theory, but that's because these are supposed to be experimental. So I purposefully made them wrong, which is perfectly fine. So what we're going to do is we'll go into Excel, and the first thing I got to do is I got to transfer over the data. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yes, I know you can drag, but just for the sake of getting this going, who cares? As I enter over the data, from assuming that what you see on the right was written by hand, and you'll see that it's not very well organized at the moment. I'm pretty much done with this, so I don't need it anymore. I personally like to use Times New Roman. You can use whatever font you like as long as it's legible. I also like to use 12-point font. In order to select everything on the spreadsheet all at once, just hit Control A and voila. Now you'll notice that these are all 1 digit, these are all 2 digit or 3 digit. If I want to make this nice and neat, I can go ahead and add a decimal place up here by moving the decimal however I would like. I'm just going to stick to giving everything 2 sig figs, except for this 10, which voila. Okay, so we'll do height in meters, and we'll do time was done in seconds. You can abbreviate with an S and an M if you prefer, that's fine as well. What I will do is just drag these along, blah blah blah. If you've made a data table before, this part's probably relatively boring. So I've gone ahead and inserted some borders for the data table and made it nice and neat. Now let's go ahead and say I want to make a graph off of this data. So what I would do is, before I actually show you how to select it, I'm going to show you another important thing that you'll need for a lot of labs, and that is figuring out what exactly is in relation to what. So what we see now is my data table, which is incomplete, although at first it doesn't seem like it's incomplete, but it's not going to produce a straight line, and I want it to produce a straight line. So I'm going to title this first off height versus time. So before I make the graph, I need to decide what kind of data do I actually want. So what I'm going to do is take a look at the physics equation that would fit for this experiment, given a certain height and told that the fall time is X amount of seconds. Find the acceleration due to gravity. Since the ball was dropped from rest, there is no initial velocity. Delta y is, I'm going to replace it with h because it's my height. I have a 1/2 g. G is the acceleration due to gravity, and then t squared. Now, I want you to think in terms of independent and dependent variables. H is my independent variable. Mathematically, that means h is x. And then time is my dependent variable, and mathematically that means time is y. And I'm ultimately going to build the equation y equals mx plus b. So I'm going to rearrange this existing equation just to make my life easier. I'll go 1/2 gt squared equals h. So my first step, all I did was flip what's left and what's right. Move, multiply both sides by 2, divide by g. That's going to give you t squared equals 2h over g. And then our final step would be, let's go ahead and say, take the square root, 2h over g under square root. That's what time equals. Now this leaves me with two options. If I were to go ahead and graph time h, as you can see, this is a square root function. It's going to produce for me a square root graph, which is exactly what I do not want. I want a straight line. So in order to produce a straight line, I have two options. I can take a look at this here, and I can see that h relates directly to t squared. Or if I use this one here, I can see t relates to the square root of h, which means I need to take this data, whether it be taking all the times and squaring them, or taking h and putting them all under a square root. I have to modify the data. I'm going to, for the purposes of this demonstration, since I don't really like square roots, I'm going to go with this model. So I will take all of my time values, I will square them, I will put x, the x-axis is h and the y-axis is t, and as I get my plot, it will go ahead and form a straight line. I'm going to use Excel to make this line for me and to tell me the equation. But one thing I want to talk about really quickly with this t squared business that's going on, if I bring this here, I want you to think about y equals mx plus b. We'll put a plus 0 here. That's to symbolize there is no y-intercept. And there's no y-intercept because if the ball was dropped at a height of 0, the fall time would be 0. So it makes perfect sense that the y-intercept is 0 and it goes to the origin. The independent variable, x, is the height. The dependent variable, y, is t squared. And then everything that's left over is the slope, which is 2 over g. So I can say that the slope of this line will be 2 over g. Next thing I'm going to do is I'm going to go into Excel, and from Excel I'm going to go ahead and take all the times and square them and build the graph. So what I want is t squared in seconds squared. Expand this. And alright, so instead of using a calculator to solve all that, that's no fun. I'm just going to hit equals, click on this cell, caret 2, that squares it, and instead of typing that 9 more times, I'll just grab this box, drag it down, voila, there it is. So I'm getting pretty close. I'm now ready to make my graph where t squared is the y-axis and h, or height, is the x-axis. So in order to do that, I'm going to first select the data. So I have the data, and I have, notice I selected height in meters, and I selected the time squared. I'm going to insert a scatter plot. We always want a scatter plot. We do not do connect the dots. We always do a scatter. So I'll make this height versus time squared. I can do some extra things with this graph that you want in every single report. I'll give it an axis title. So the horizontal axis is height in meters. Then the vertical axis will be time squared in seconds squared. You can make it a little bit bigger if I want. And finally, I need a best fit line. So what I will do is I will click on one of the data points. I'll right click it. If you're using Google Sheets, I believe, I'm not 100% sure, but I believe there's an option on the right side of the screen that you click. But for Excel, I just go to add trend line. And there it is. It gives me the option to choose what type of function I would like. I purposefully linearized the data, so it should be a line. To make life even easier, just click display equation. Voila, there it is. At this point, you can see that I have y equals 0.1962x plus 0.1225. So it did give me a y-intercept, which can be attributed to error, and then it also gave me here a slope. Now that I've concluded building my graph, I'm going to take that slope of 0.1962 that Excel gave me, and as I said earlier, the slope equals 2 over g. So I'll put 2 over g, solve for g. G is 2 over 0.1962. So 2 divided by 0.1962 comes out to 10.2 meters per second squared. So we actually got an acceleration that's greater than Earth's. That makes sense. There should be error in lab. The last thing is to calculate a percent error. To calculate a percent error, what we're going to do is take our value of 10.2, subtract the 9.81, put it in absolute values because we want a percent error, so we don't care positive or negative. So force it to be positive by putting the top in absolute values. We divide it by the theoretical value of 9.81, and we multiply everything by 10%. So 10.2 subtracted by 9.81, divide the whole thing by 9.81, multiply by 100, I got 3.98%. So 3.98% error would be the error for this lab.